Welcome back to our journey with TypeScript. In our previous session, we explored decorators, powerful tools that let us attach behaviors to classes, methods, and properties without cluttering the core logic. Now we will look at from the architecture's reliability standpoint, because even the cleanest system breaks if your code can't safely handle the most common real-world issue in JavaScript, null and undefined. And to understand this, let's step into a world that deals with partial data every second. Imagine you're building a smart city monitoring system, which has sensors installed at traffic counters, weather stations, and street cameras, all streamlining data into your dashboard. But here's the problem: sensors may fail, batteries may die, networks may fluctuate, and when they do, some values simply don't arrive. You now face the number one reason production JavaScript apps crash: trying to read a property of null or undefined. TypeScript solves this through a trio of null safety tools. Strict null checks. Assume nothing. Treat missing data as a real possibility. Optional chaining. It accesses values safely only when they exist. Non-null assertion. I know this value is present. Use it confidently. Let's walk through each one inside a smart city system. So let's explore the first one, that is strict null checks. This we can imagine as the sensor reliability mode. When strict null checks is enabled, TypeScript stops pretending values always exist. Just like a monitoring system must consider a sensor might go offline, strict null checks forces your code to acknowledge missing data. Without strict null checks, TypeScript assumes everything exists, which is very dangerous. With strict null checks, you get compile time errors when you forget to check null. So let's see with a code example. So let's say I have a sensor to get the temperature. So that is get temperature reading, let's say, which is a number. Now this temperature reading is a number, but not always will the sensor give me a reading. It may also fail. So I'll also add one null over here. So it may also return null. I will say return. Let's just return some mat.random 1.5, or it is like that temp equal to get temperature reading. Let's call this function. If not equal to null, then current temperature is less, else temperature reading unavailable. Yeah. Okay. Let's try this code. Yeah. As we can see, it is 27. Let's try it again. Dot random. Let's say it should fail. Yeah. So as we can see, sometimes our code returns a value and sometimes it doesn't. So with null safety checks, with strict null checks, we can ensure that our application doesn't crash when the data doesn't arrive.
Why is strict null checks considered essential for reliable TypeScript architecture?
See, in our application, we use many APIs. And the issue is we can't rely on the API always returning a response. There may be some server or network issue which may cause any API to fail or not return a response. In that case, if we expect that the API will return a response, and based on that, we have our further piece of code, that time our app will crash. So if we put this null checks over there, that this particular value, in this case, the temperature. So over here, I'm relying on the sensor data. So the sensor may
Mm.
return a data, but in case it doesn't, then also my app doesn't crash because I've handled the null data over here. So in case
Mm.
my sensor doesn't return the data, I've handled it saying temperature not available. So it doesn't crash my app over here. Now, but constantly writing manual checks becomes exhausting, especially in a city where dozens of sensors might fail at any moment. So TypeScript gives us tools to simplify safe access. That brings us to the next concept, that is optional chaining. Optional chaining is like, if the sensor responds, give me the value. If not, don't crash the system. Just give undefined. So instead of saying like, let's say, like, if, let's say my sensor, and then I will have another, let's say if it is sensor dot, let's say details, and then I will have another if saying sensor dot details dot, let's say the location of the sensor. So having multiple, instead of doing this, having multiple if statements, what I can do in TypeScript is I can write all these three ifs into a single line. So that is, let me just remove this. What I can do is I can just write sensor dot details dot location. I can do this. So let's see with a code example. So let's say I have a air sensor, air sensor, which will have an ID, some this one, yeah. Let's say the data is month dot random in 100. Quality is 92, else it is null. Sorry. Yeah, yeah, we can do this. So let's say it is greater than 0.5. Let's see. Yeah, let's try this code. Mm, it is coming from here. Let me just comment this. Yeah. So as you can see, the first time my air sensor returned some data. So that time my air quality was 92. But the second time my air sensor didn't return any data over here. So that time my app should have crashed if I had not done the type check over here. So since I had handled it, it just showed me that data is unavailable. So this condition.
So, what are the scenarios in which we can prefer optional chaining over null checks?
Now in this case only, I'll give this example. So
Yeah.
let's say my air sensor, I can access this air sensor object. I can also access, let's say, the data attribute of this. But let's say this particular sensor has not recorded the air quality. So at that time, I can't access this quality property. So in that case, my air sensor data is there, my this data object is also there, but just this quality is not there. At that time, we will use this optional chaining method. Null checks is when, let's say the API, you have any API which may or may not return any value. In that case, we can use null checks, strict null checks, but optional chaining we can use in this scenario where
Yeah.
we can access some data, but some data may or may not be accessible. So optional chaining keeps the system running even when sensors fail. But sometimes you actually know that a value must exist. Maybe the system validated it earlier, maybe it's guaranteed by infrastructure. That's when the third tool comes in. That is non-null assertion. Non-null assertion operator tells TypeScript, I have already verified this value. You don't need to warn me. It's like a technician marking a sensor. So let's say, let me just comment this code. Let's say my camera feed is of type string, or it may be null, is, let's say, my dot random is greater than 5. Let's say active or yeah, inactive. Let's say this. Or let's say I'm getting a live feed over here, or I'm not getting anything. So in this case, it will be null. Yeah, this will be better. Null. Yeah. Then if my not camera feed, let's say I'm not getting the camera feed, in that case, I want to throw an error. Camera feed is not available. Yeah, let's throw this error. Let's console.log. Camera feed status is this. So this. Yeah, perfect. So what I've done here is first I'm checking if there is no camera feed. In that case, I'm already throwing an error. So here, what I've done is I have done the non-null assertion over here saying camera feed. I've already checked for the null field over here. If this particular camera feed is null. So you don't have to throw an error again. That is what I'm telling TypeScript over here. So let me just run the code. Camera feed is not available. Yeah. So in this case, the camera feed was not available. And see, now it is available. So this is how TypeScript will handle the non-null assertion.
What are all the real risks of using this operator?
Risks of using non-null assertion. Yes.
Yeah, yeah.
Okay. See, in production systems, like in this case only, like I'm getting the camera feed, but as you saw, the first two times I didn't get any camera feed. So that time, if I had not done this non-null assertion, what it would do is it would check for this, and then again it would go in this console log. It would say camera feed is not available. So it would again throw two errors over here. So one was coming from this if statement, one was coming from this console log. But with this non-null assertion, what I'm doing is I'm just asking TypeScript to throw the error just once. So because I've already checked the camera feed value. So if it is null, then throw this error. If it's not null, then you can proceed and console log the camera feed status. So this way, it actually, let's say I'm not just console logging this camera feed. Let's say further, I'm doing some processing on it. I want to, let's say, detect the faces in it. I want to do some processing. So in that scenario, if my camera feed was null, it would create an issue in the further part of my code. So because I have asserted that I have checked it to be null, it won't it won't crash my app over here. But there is one warning actually over here. So use this non-null assertion uh, only when you are sure that that value will be there.
Mhm.
It bypasses TypeScript's
Yeah,
actually
yeah.
safety net over here. So here is what we learned. Sensors may fail. Strict null checks catches unsafe code. Missing data, optional chaining lets you read safely. Validated data, non-null assertion lets you use it confidently.